Good morning, dear students. I am Dr. Srinivas Battini, Professor of Chemistry in St. Peter's Engineering College. Okay, today we are going to discuss about the secondary battery cells or lead acid storage cell. What is the topic? Lead acid storage cell. Lead acid storage cell or lead acid storage battery. In the last video, what we discussed? We have discussed what in the last video? Just introduction of the batteries and types of batteries. There are three types: primary batteries, secondary batteries, and fuel cells. Primary batteries example is the lithium cell, and secondary battery example is the lead acid storage cell. In the primary, anode and cathode, one electrolyte is there. So that three are. But that is a not reversible reaction. The primary cell is not reversible. Whereas in the secondary cells, these are the reversible. Reversible mean what? Both forward and backward. Forward mean one is the discharging and recharging. So in primary cell always discharging. Once you have to use, then it will not again and again use it. But in the case of reversible mean discharging and charging again and again. We can use many times, only single cells. Okay, now, so lead acid storage cell is what? A lead acid storage cell is a secondary battery. That is the one point we can write. And which can operate both as a voltaic cell and as an electrolytic cell. Voltaic cell. That acts as a voltaic cell. Voltaic cell. Voltaic cell. And electrolytic cell. Both. Lead acid act as a both voltaic cell, act as a voltaic cell as well as electrolytic cell. So what is meant by voltaic cell and electrolytic cell? We studied already in intermediate. When it acts as a voltaic cell, it supplies the electrical energy. What is that? It supplies the electrical energy. So when lead acid acts as a voltaic cell, it supplies the what? Electrical energy. When it acts as a voltaic cell, it supplies what energy? Electrical energy. And becomes a run down. Mean we are using. Becomes run down. When it is recharged, the cell operates as an electrolytic cell. Here, recharge. Recharge means the electric current stored in that one. Stored in acid battery. Mean when it is recharged, the cell operates as an electrolytic cell. So this is about, so a lead acid acts as a voltaic cell as well as a electrolytic cell. So if we can draw the battery structure, we can understand very easily. So first of all, so we will draw diagram. So in the diagram we know already what is there. The anode and cathode is must. Anode is left side and cathode is the right side, and one is the electrolytes. That one already we seen in which lithium cells. So today we have to discuss the secondary battery, that is the lead acid battery. So the diagram is, just look at it. So here one battery cell. This is the lead acid battery. This is the battery cell. So in this, we have to fill electrodes. So these are the electrodes. One is anode, another one is the cathode. This is the cathode cells. So 3 cells we are using and connected. These are the 3 are connected 3 parallel plates. So this is the what? Cathode, you can say. And this is the anode. And we have to fill sulfuric acid electrolyte. Electrolyte. These are the 3 main important: cathode, anode, and this is the battery. So electrolyte we have to use in this sulfuric acid as in their polymer, that is we have used in lithium battery, but whereas in this we have to use the sulfuric acid H2SO4. But here cathode is what and anode is what. So anode is a what? Lead plates. We can use the lead plates. So the blue color, lead plates. And here the red color, Pb, what? Lead oxide plates. These are the lead oxide plates. Lead oxide plates. So this is about the what? Construction. Construction of acid storage battery. Construction of acid storage battery. So what is there? One anode is there, one cathode is there, and anode is a lead plate, cathode is a lead oxide plate, and electrolyte, that is sulfuric acid. So This is about the diagram. And so in the theory, how can you write in three? Just 3-4 lines you have to write in this. That I will explain you. So what we have to write in the examination. So lead acid storage, the definition is over. Then draw the diagram. And now a lead acid storage battery consists of 3 to 6 plates. So 1, 2, 3, 4, 5, 6. 3 anode plates, 3 cathode plates. Just we have to write the lead acid storage battery consists of 3 to 6 voltaic cells connected in series. Voltaic cells, these are the. And to get the 6 to 12 battery, that is the 6 to 12 battery will come. In each cell, the anode is made of lead. This is the one cell, is a plate cell, that is a one lead. The anode. And cathode is made by the lead oxide. In each cell, the anode is made lead and the cathode is made up of lead dioxide. A grid made up of lead and packed with PPO2. Means lead dioxide. In this, you have to, in a grid, lead dioxide. So lead dioxide packing is there. And connected in a parallel way, lead oxide and lead plates and lead oxides, cathode and anode, one by one, and also adjacent one by also. And between there, insulator. This is called the insulator. What is that? Rubber insulator. Insulators. White color is the insulators. We can use the fiber glass fiber or rubber we can use. So what is there? 3 to 6 cells are there arranged in a parallel way. So that is anode cells and cathode cells. Anode is the lead and the cathode is the lead oxides. And this is the lead oxide build method. This is about we have to write in the theory level. The entire combination are immersed in sulfuric acid. The entire combination. So first of all you have to make it and in a sulfuric acid. This is the sulfuric acid. That is act as a electrolyte. The entire combination are immersed in sulfuric acid. So sulfuric acid is what is the density of sulfuric acid and how much percentage is there. Actually sulfuric acid is the 38% sulfuric acid. How much? 38%. 38% sulfuric acid. By mass, we can say by mass. And the density is, how much density is the 3.4 grams per ml. Density is 3.4 grams per ml. 3.4 grams per ml. This is about the description, construction, then description. So we can write that one. Okay. And the cell, the representation of cell is important. We will get the 1 mark for the representation. So what is the representation? Here, what will happen? So the representation is more important. So what is the representation? The representation is, we know that lead sulfuric acid, we will get the lead sulfide. So just we write the representation. Representation in cell notation. We can say cell notation. PbSO4. PbSO4. Like this. And sulfuric acid and lead oxide and Pp. This is we can write lead sulfate, sulfuric acid and lead dioxide and lead. This is the cell representation. This is second point. First point, introduction And second point, construction. Third is the description. And fourth is the representation. And fifth one is the working. In working, mean discharging. We can say discharging. Working condition means we are using the battery. After 1 hour, the battery is slowed down. Then again we are doing the charging. Charging and discharging. So what happened in discharging? That is very important in this battery. So charging, when the lead acid storage battery operates. So in this also, anode is there, cathode is there. Working condition at anode. At anode, what is there? Lead is there. At anode is the lead. Lead is oxidized lead plus 2. At anode, lead is oxidized to lead plus 2. And immediately, what is there in this? Sulfate, sulfuric acid there. The sulfate, it reacts with the sulfate. So Pb plus 2 react with the sulfate to form the lead sulfate. Lead sulfate. Mean this is what solid will come. So this is the charging, discharging, and if it's reversed mean charging, recharging, discharging, recharging. Mean I can say charging. You can say discharge and charge. The forward reaction is the discharge, means it's working, and backward is the recharge. Okay, lead lost 2 electrons to form the ions and to react with the sulfuric acid to form the lead sulfate. At cathode, at anode, and at cathode. At cathode, what happened? So in cathode, lead dioxide is there. So lead dioxide, same thing. Lead dioxide is reduced to lead plus 2. So mean the lead oxide ions, lead dioxide, its loss are reduced to lead ions, and which further combines with sulfate forms the insoluble state. Same thing happened whatever in the anode and also here happened. Mean immediately it react with the sulfate to form the lead sulfate. So that is the mean same Pb, or we can write direct reaction PbSO2. No need to write everything. And H plus means sulfuric acid, H plus sulfuric acid, and SO4 minus 2 and 2 electrons to form the PbSO4. This is about the PbSO4. And what is there? That water also will come. Water also. Silic H plus ions. Oxygen is there. Lead sulfate. And what about the lead dioxide mean? So lead dioxide means, so if 2 moles, 2 moles or 4 moles, then H2O will come to H2, 1H2. So this is the reaction at a cathode. So in the working condition, that is the discharging. So what happened at anode, the lead lose the electrons to form the L plus 2 and immediately react with the sulfate to form the lead sulfate. At cathode, at anode, at cathode, that is at anode, and at cathode lead dioxide is there, that is also to form the lead dioxide reduces to lead plus 2 and immediately the lead plus 2 react with the sulfuric acid to form the lead sulfate and plus water and dilute it. This is, so that what is the overall reaction? We can write the overall reaction. So what is the overall reaction? Lead and lead dioxide. Don't write this one, okay? So direct we can write lead. Direct we can write lead dioxide and Pb, and H plus and SO4 and 2 electrons, only 2 electrons, and PbSO4 and water. This is, we can write. So what is it? This is the lead dioxide, and H2SO4 and 2H plus or H2SO4. Directly we can write the H2SO4. 2H2SO4. Okay? 2H2SO4. And 2 moles of lead dioxide. Discharging and charging. Lead sulfate and water, and then the important, this is the reaction, but is finally what will happen? That is the most important, is the energy, the release of energy. The overall reaction, the release of energy. So that is, this is the chemical energy converted into the electrical energy. Chemical energy converted into electrical energy. So this is it where in working condition, the first of all in the working condition means discharging the cell. So working condition means discharging means lithium react with the sulfuric acid to form this one PbSO4 and water molecule. So mean the concentration of sulfuric acid is decreasing and energy is releasing. The concentration, the first we have to feel the concentration is decreasing, and precipitation, PbSO4 solid precipitation is formed and energy is released. So this is happened in mean. So once again, what is that? From this reaction, it is clear that the lead sulfate is precipitated at both the electrodes, here and here, both the electrodes, because and sulfuric acid is used up. As a result, what happened? The concentration of sulfuric acid decreased and the density of sulfuric acid fall down into 2.4. Actually 3.4, the density is the 3.4, and after the using of 1.2, so the density is decreased. So mean we can say if the density is decreased, mean that's already we have used the concentration of sulfuric acid, because water is there and sulfate is there, so that is the reason. So all these things we can understand. So energy is released mean we are used the battery. So the battery is work done. Okay, now recharging, this is about, please note down all these things, the battery construction, and this is the notation, and working condition are mean discharging. Okay. Most important is mean originally 3.8 density gram per mole, and after using it fall down 1.2 gram per mole. After this is the difference in object type question paper also they are asking. So now recharging the battery, recharging. So recharging we have to recharging or charging the battery. The cell can be charged by the passing what? Electric current in the opposite direction. The electrode reaction, the reaction gets reversed, mean for not reverse mean backward direction. As a result, lead is deposited on anode, and lead dioxide is deposited cathode. Lead dioxide is deposited on cathode. The density of sulfuric acid from 1.2 to 3.8. This is about the charging. Same thing. First, lead to lead plus to lead sulfate. Lead dioxide to lead plus to lead sulfate. And 3.8 to 1.2. Now all these things reversed, mean back. So the lead sulfate to lead at anode side, and lead sulfate to lead dioxide at cathode side, and sulfuric acid from 1.2 grams density to 3.8 density. This is happened in recharging the battery. So what is the reaction? So in charging means that we have to record the electric charge, means energy we are taking, the energy. So current, electric energy, we can say energy plus what is there inside? PbSO4 and what is there? Another water is there. Lead sulfate is there, water is there, energy is there. Lead sulfate, water and energy. So these are present in the after working condition. And density is 1.2. 1.2. There is no sulfuric acid. Sulfuric acid. Okay. So here what happened? So lead sulfate to form the lead dioxide as well as lead and sulfuric acid. So Pb plus PbO2 and sulfuric acid. Pb at anode side, PbO2 at cathode side, and H2SO4 in the tank. So this is the recharge. And passing what? Energy. So this is the electric current. Electric current. So when we supply the electric current to the battery, then it is converted into lead and lead dioxide and sulfuric acid. The storage of the chemical energy. The current electricity is storaged in this one. So this is happened in the reaction. This is the most important. This is only just one reaction. No anode, no cathode. So in working condition, 2 at anode and at cathode. But now overall reaction, we have tried the lead sulfate and water is there, and sulfuric acid 1 point density is there. And when current is passed to this battery, then what happened? So that lead sulfate the lead is deposited at anode side and lead dioxide is deposited at cathode side, and water and sulfate to form the sulfuric acid. So these are the some of the reactions in the lead acid storage batteries. And advantage, we have to look the advantage. So what are the advantage? What are the advantages of acid battery? It is made very easy. See, simple. Anode plates, cathode plates, and put in immersed in a battery. That is, we can company, the civil and mechanical engineering student make a battery companies, manufacturing batteries. So these are most useful. Everybody is can in a car, in a bike, buses, lorries. Many batteries are there. So if you have money, so 1 crore or 2 crores, invest it simple batteries. I will help you also. I will work in your company. Okay. It produces very high current. So simple, it is a very simple made symbol and produce a very high current. The self-discharge rate is low when compared to other rechargeable batteries like cadmium batteries. Self-discharge rate is very low when compared to other batteries. It is also act as effective at low temperature. At low temperature in the winter season also it can be useful. In winter season also, if you on it will work. Some of the batteries will not work in winter season, but it will work in the winter season, low temperature. And what are the disadvantages from this one? So disadvantage is a very drawback this one. The sulfuric acid, the lead sulfate is the main problem. The recycling of this battery causes environmental hazards. Lead sulfate and diluted 1.2 dilute sulfuric acid is there, and a lot of water is there, acid is there. Environmental hazards, environmental is there. So mechanical strain and normal bumping reduce the battery capacity. Clear? So what happened? The bumping takes place. In the bumping, the jerks takes place. During the jerks, the battery capacity is reduced. That is the main drawback. Smooth driving in smooth roads, it will be very useful. Of course, environmental causes is there, and we have to use core very smooth way. If you are using the rough way, the battery will reduce in few days only. And what are the uses? Finally, the uses are what? Lead storage cell is used to supply current mainly in automobiles such as cars, buses, and that will you can write. So driving buses, cars, and even two-wheelers. It is also used in a gas engine ignition, gas, LPG gas, gas cars, and telephone exchange in the hospitals, power stations for ignition. So these are the main uses Okay, so today what we have discussed in this, today we have discussed the lead acid storage cell. That is what it's a secondary storage, secondary cell